Okay, here at the beginning of Unit 4, dealing with triangles and congruence. Some of the cells deal with just mainly the properties of triangles, but we also have some units that will talk about how we prove that triangles are congruent. Congruent meaning that they are equal in every way. So to start out with some of these proofs, we have to have reasons for those. So we're going to start here with algebraic reasoning. And basically it's going to bring in to something new with something you've already had. So these are things, most of these you've had before. Maybe you didn't think of it this way, but really these are the reasons why we can do what we can do in algebra. All right, so we're going to go through a whole list here and then we'll do some examples. So the first one is just called the addition property. That basically says if I have two expressions that are equal to each other, such as A equals B, then I can add the same amount to both sides and it's still legal. Okay, so just like when we were in algebra and solving equations, what I do to one side I have to do to the other. They're still equal then, so the reason I can do that is property of addition, or just addition. Subtraction is going to work the same way. If we start with this, remember that from science class, if then statements, hypothesis, conclusion. So if I know this, then I can conclude if I subtract the same amount, then it's legal. Multiplication, again, we're going to start with something that we know. If A equals B, then I can multiply both sides by the same amount and it's legal. Or we have a reason why we can do that. And division is if I can divide both sides by the same thing, then that's okay. That's an okay step to do. And all four of those you did like every time you solved an algebra equation. The only thing we have to be careful here is that C, the number we're dividing by, cannot be equal to 0. You know, because the first commandment in mathematics is thou shalt not divide by 0. It gives you an undefined result. Distributive property. Again, you use this in algebra also, that when I have a number outside a expression with a plus or minus, then I can distribute that A so that it multiplies to both of these interior numbers. Okay, so whenever I see this and I do this, that's called distributive property. Substitution. If I have two expressions or equations that are equal to each other, then one of them, in this case A, may be replaced by B in any expression or equation. So with substitution, if I know two things are equal, or I have one, I can put the other. They call it replaced or substituted back in. Now those are the ones that you've done from algebra. These next three won't make a lot of sense right now, especially this first one. We use this a lot in our geometry proofs dealing with triangles. It's called the reflexive property. Okay, so reflexive kind of has a like word of reflection. So basically any number, any real number, will equal itself. So if I have any real number A, then A is going to equal A. Now that A could be a number, like 10 equals 10. It could be a variable, M equals M. But it could also be like angle 3 equals angle 3. Okay, just whatever value we have, it's always going to be equal to itself. Symmetric property is, again, we're starting with that same thing. If A equals B, then B equals A. Okay, so where this one kind of comes into play is when you were solving your algebra equation and somehow you ended up with X on this side. Okay, and then for your answer, you just wrote it down like this. And you didn't think anything of it because, well, that means the same thing, right? Well, the reason it means the same thing is something called the symmetric property, that if I have two equal values, I can switch them around and they're still going to be equal. Okay, symmetric will switch the expressions around. Transitive is like a double substitution. So if A equals B and B equals C, then A equals C. So you'll notice this one, all these just had if A equals B, if A equals B, if A equals B. This one has an and to it, so there's like two pieces to this one. There also will be two pieces to the substitution one. But here, if these two values equal the same thing, then they are equal to each other. That's called transitive. If these two equal the same thing, then they're going to equal each other. Why can I say that? The transitive property. Sometimes you'll see, like right here, it doesn't always have to be these two middle ones, but there's kind of like a bridge there so that they both equal B, so then the first one equals the last one. All right, so let's see how these are used. Most of these will be if-then statements. So let's go through here. So if k equals 3, then 3 equals k. What you're doing to help you name that property is, what did they do to this to get this? What did they do to the if to get the then? And in this case, they just switched those two around. That's called the symmetric property. Number 2, here's an algebra equation. 2x equals 14, then x equals 7. Well, if you were going to solve this equation in algebra, what would you do? You would divide by 2 to get that x by itself. So when you do that, the result is x equals 7. So when I do this and divide by 2, this is the result. That is just division. Third, 10y equals 10y. So that is reflexive. If something equals exactly itself, there's no if, there's no then, it's just reflexive. Number 4, just like up above, if I have this algebra equation to solve, to get this by itself, I would add 1 to both sides, and when I do so, this is the result. So this would be add, or addition. Sometimes they'll put like what you're adding, or what you're dividing. This one dividing by 2, this one was adding 1. Number 5, 10a equals 2b, and 2b equals c, so then 10a equals c. So look where those are at, 10a and c. They both equal 2b. We call that the transitive property. Remember, if two values equal the same thing, then they equal each other. Number 6. Okay, I think you can see this one from the algebra. If I would take this -7 and distribute it across those parentheses, that's distributive property. Okay, 6y equals 24, then 6y minus 3 equals 24 minus 3. So what did they do to both sides? As long as they do the same thing, they subtracted, or subtraction. Again, these little numbers over here, that's just telling me what I've subtracted by. You don't have to put that in there. It just is a helper. Number 8, here's my equation, and I know this. So how do I conclude or come up with this? So one way is you can see that this equation here and this equation are pretty similar to each other. I'm going to put this one right above this one. Watch. Pretty similar to each other, aren't they? Okay, the only difference is where there was a w, now I have a 1. Well, how come I can do that? Well, because w equals 1. Wherever there's a w, I can replace it with the 1. And that's exactly what happened here. Replacement is substitution. All right, why don't you stop the video just a second and do those 9 through 14, and we'll come back and show you the answers. All right, number 9 is transitive. Number 10 is addition. We're adding 4 to both sides. Number 11 is going to be symmetric. Again, you're looking to see what did they do to this to get this. And that one they just switched it around. Number 12, I'm given this, and I also know x equals 5. How is this different to this? In place of the x, they put a 5. And anytime you say in place of, that's called substitution. (13) What did they do to this to get this? Now, you always go from the if to the then. Because most of the time we're used to this, and we divide by 8, and this would be our result, right? Well, this one is, if I know this, I'm going here. So that's multiplying by 8. And our last one is distributive. It's kind of a reverse distributive, but still case. All right, we're going to end there, and then we'll go on to our second page of notes dealing with some proofs.